Very good morning to everyone. So midterm is coming. Next Monday is our midterm. 3:30 to 5:30. At link 3. If you can come at least 3:15. If everyone arrive earlier, then we might have a reading times about 10 minutes before the exam start. So I know that you guys have a class until 2 on Monday. Can you let your teacher or lecturer know? Must give you guys leave at least 10 minutes early. Tell your lecturer before the class start, so that he or she can. So bring your student ID. Remember, bring your student card. Okay. Bring your stationery. Put in a clear bag, or just bring your stationery. You can bring calculators, the scientific one, but not practical one. Dictionaries and other electronics are not allowed. So any breach of instruction or cheating will cause you be chased out from the exam hall. I think the entry, I haven't been there before. They gave me this layout here. So we have 3 groups. I guess since the whiteboard is here, we should be facing the side. So we have Tuesday, Wednesday, and SWE here. Okay. So just maybe not of the whiteboard. What did I draw? Then SWE will all sit in the whole block. Okay. So one row is like 13. So start occupying the row here. And keep going. 13. The number here about 67 should be enough. Okay. Enough. Maybe not enough. Okay, we will see how. Then maybe we'll mix with the other guy. Okay. Yeah. So on your exam table, you should have your student card. You should have the attendance slip from the booklet. After you fill it, you should tear it down and put together with student ID so that we can take attendance. And then stationery or clear water bottle. And you will be given exam papers, answer booklet, and draft paper. Okay. Any question regarding the exam or not? I think this one, I go through this thing with your class already, right, last week. But this one, just to remind you again, the name of the law, this is not given in the exam. Only the table is given. Okay, this is a conditional extension economics. This one I mentioned last week, right? Okay. So extra office hour. So I moved the office hour next week to today, to 6 in my office. If too many of you come, then we'll move to a classroom. Okay. Anything to ask for lecture exam or lecture last week tutorial session? In some of you spot some mistake in my solution, I already changed it from the website. Or counting the TCB. Anything from last week? No. Today, some part maybe I'll go a little fast, so just follow me. Maybe we'll do some warm up first because from the last two class they are confused in the calculation. So let's do some warm up first. So let's say we want to do okay. So what is 5x minus 2y mod 2? Okay. Anyone know how to compute this? Answer here. What is 5x minus 2y mod 2? Like you think of. What is 5x minus 2y mod 3? Any idea what is 5x minus 2y mod 3? Any idea? Five x 2y mod. Huh? What? 5x? Just 5x. 5x compared to what? Again, 5x compared to what? Huh? 2y? Uh, no, no. Any other answer? 5x minus 1 mod 3. What is 5x minus 1 mod 3? Minus 2y. Any other answer? Feng got answer. Huh? No. 5x minus 2y mod 3. Okay, my answer is 2, right? Okay, so so let's recall how to do this calculation here. So when you want to do the sum mod 3, you can do mod 3 individually. Okay, you can do mod 3 on this 2 bit here. So perfectly. So I should right here. Actually, there's a plus here, right? And from the theorem last week, if you want to do um if you have congruence B mod M A and B and then C and D mod M. Okay. So if you have this, then you can add them side by side, or you can multiply them. Okay. So you can do mod 3 on both of these, and then since they are the product, right? So you can do mod 3 on the factors as well. Okay. So that means you can do mod 3 on 5 first, and then do mod 3 on x, and then multiply them together. Okay. So 5 mod 3 is what? What is 5 mod 3? 2, right? So 5 mod 3 is 2. X, we don't know what is it, so just leave it as x. Okay. And then what is minus 2 mod 3? 1. Why? Because, okay. So one reason is because, okay, let me write it down first. So why minus 2 mod 3 is 1? Okay. So minus 2 is the number that add to 2 mod 3, you get 0. Okay, you get, I'm sorry, I should write. So get modulo 0. Okay. So minus 2, because minus 2 is not in Z3, right? So what is Z3? Recall what is Z3? So Z3 is 0, 1, 2. Okay. So minus 2 is not in the set, so you need to pick something from the set. Remember last time I asked you to find the inverse, additive inverse. So minus 2 is actually 3 minus 1, 3 minus 2, okay, which is 1. And then 1 is in Z3. Okay. Recall from last time how to find the additive inverse. Use your M and then minus the number. You need to see the slide last time. Maybe I just show you. It is in the slide I'm talking about, this one. Okay. So how you find the additive inverse? Take M minus A. M minus A. Okay. Just now the A is 2. Okay, right? And what is minus 2 is M. So our M is 3. 3 minus 2 is 1. So the inverse is 1. Okay. Okay. So this one is 1, and then y mod 3 is 1. So we have 2x plus 1. Okay. So altogether we have 2x plus 1. Okay. Any question or not? This one you have to know today, because if you don't know, then you will be blurred for the whole selection. Okay. So last time we say that every number have a additive inverse, right? Just as what I showed just now. So you put is congruent to 0. Okay. So for every a in Zm, okay, we have a plus m minus a is congruent to 0 mod m. Why? Because a plus m minus a is m. N mod m is 0 because m is divisible by 0. Okay. The remainder after m divided by m is 0. So there's another question is, does there does there exist multiplicative inverse for every a in Zm? Okay. So does there exist a multiplicative inverse for every a in Zm? So what do I mean by that? So let me call the inverse. We call for a bar. Okay. So what do I mean by that? So for every a in Zm, then this a bar is such that a bar equal to 1 a bar a no. Okay. So maybe for example, let's look at two examples here. So one example is let's see, just there is this a bar for 3 such that 3 times a bar is 1 bar 7. Okay. Just there is this 2 times a bar such that it is mod 4. Okay. So the question is, can you find a bar such that 3 times a bar is congruent to 1 mod 7, or can you find an a bar such that 2 times a bar is congruent to 1 mod 4? Okay, I let you try, and if you can find an a bar for 2 minutes. So this a bar here should be in Z7, and this a bar here should be in Z. Yeah. Yeah. Whatever. So does there exist a bar such that 3 times a bar is congruent to 1 mod 7? Anyone try or not? I think there are 7 numbers for you to try here. 5. 5. Let's see, 5. Okay. So 3 times 5 is what? 15. So what is 15 mod 7? 15 divided by 7, 14. Remainder is 1. So it's 1 mod 7. Okay, yeah. So a bar for 3 is 5. How about part 2? Can you find an a bar such that 2 times a bar is 1 mod 4? No, right? Because 2 times 0 is 0, which is 0 mod 4. And then 2 times 1 is 2, which is still 2 mod 4. Just sure we are lazy. Okay. And then 2 times 2 is 4. 4 is 0 mod 4. 4. And then 2 times 3 is 6, which is 2 mod 4. Okay. So what can you see here? So 3 and 7, actually they are relatively prime, or the GCD is 1. Okay. But 2 and 4, the GCD is 2. Okay. So there's something to do with the GCD. Okay. So here lead to our theorem here. So the theorem is, if the GCD of A and M is 1, okay, and M of course need to be greater than 1, then there is an inverse that is A inverse A congruent to 1. Okay, you might wonder why I put left and right. So here is like left inverse, and here is right inverse. So when they agree, they are the inverse. But that's just technical stuff. But okay. So just now we just use inspection to find the inverse, but actually there's one systematic way to find it, which is by the extended Euclidean algorithm. Okay, so from last week, we know that by extended Euclidean algorithm, we can express the GCD back using the linear combination of the original two terms, right? So since GCD of A and M is equal to 1, okay, then there exists a linear combination of A and M such that 1 is equal to 2. Okay. Then we can take the equation mod n. So we have 1 is congruent to xf plus tm mod m. Okay. So this term is divisible by m, right? So the remainder of this term is 0. So this one will be cancelled. So what you left with is SA mod n. Okay. So S is the number that multiply to A get 1 mod m. So S is your inverse. Okay. So let's see an example. Okay. Today example will be very important, all the examples, because exam will be tested on this calculation. So just now, recall just now we find the inverse of 3 mod 7, right? So just now we just use inspection, trying, right? So to systematically find it, so we do the Euclidean algorithm, which is 7 equals to, okay, so let's write down GCD of 3 and 7 is equal to 1. So how to find this GCD? So you do the division algorithm. 2 times 3 plus 1, right? Okay. Then you can express 1 as 7 minus 2 times 3. So if you take this equation mod 7, you get you get what you get. This term is divisible by 7. So this term go away. You get minus 2 times 3 mod 7. Okay, so what is minus 2? So minus 2, you can take 7 minus 2 to find it, which is 5 times 2 mod 7. So 5 is the inverse of 3 mod 7 because 5 times 3 is 1, congruent to 1 mod 7. Okay, so this one agree with what we found just now, right? Let me, okay, so 5 is the inverse of 3 mod 7. Just now we also found 5, right? Okay. Because sometimes when the number is big, you can't test all the number. So this is a more systematic way to find it. Okay. For small number, you can do inspection. For big number, okay. So another usage for usage of finding inverse is you can find the solution of linear congruence. Okay. So for example, solve 3x congruence to 4 mod 7. So you want to find what is x? Okay, what x solve this linear congruence? Okay. So since we know that 5 is the inverse of 3 mod 7, okay, then we can multiply 5 on both sides. Okay, what do we get? We get 15x congruent to 20 mod 7. Okay. 15x, we get 1 times x, which is x. 20 mod 7 is what's 20 divided by 7? What's the remainder after 20 divided by 7? 6. Okay, so it's 6. Yeah, so x congruent to 6 mod 7 will solve this equation here. Okay. Any question? Or you want me to repeat part of it? Don't understand which part? Ah, every part? Okay. I mean this example or the previous thing? This one you understand or not? This one you don't understand. Okay, this one? How about this one? Or this one maybe. Okay, this one. Okay. Okay, first of all, do you agree that 5 is the inverse of 3 mod 7? You don't know? Okay. Okay, can. Okay. So, okay. Okay. How about I give you this example here? Yeah. Sorry? You mean it's the inverse is unique? Yeah, the inverse is unique, but I didn't prove it. Yeah, the inverse is unique. The inverse is unique. Yeah, inverse is unique. Okay, so what's the idea of inverse? So, okay, so you know that 2 times half is equal to 1, right? Okay, you know this? Okay, you know this. So this is in the integer world. No. This is in the real number world, okay? This is in real number world. And then this thing is called the inverse of 2. Okay? So this is called the inverse of 2 because it multiplies to 2, you get 1. Okay? This is the idea of inverse. But if you move this this equation into the modular world, not sure. Okay, so let's move into the modular world. 2 times half congruent to 1 mod 5. But this half here doesn't exist in Z of the Z5, right? So Z5 contains what? 0, 1, 2, up to 4. Okay. There's no half here. Okay. But I claim that there's one number inside this set that multiplies to 2, which is congruent to 1 mod 5. 3. Yes, correct. Very good. So this half here doesn't exist, so let's write it here. So we don't know what is this. I put a open inverted comma here. So I don't know what is this. Okay. So actually, it is 3. Why? Because 2 times 3 is 6. And then what is 6 more 5? Okay. 1 more. Okay. Yeah, this is inverse. Mm-hmm. Because we live in the world of Z5, because all the calculation here is based on mod 5. So when you do mod 5, everything will reduce to 0, 1, 2, 3, 4. You get what I mean? Okay, let me give you another thing. So what is 6 mod 5? 1. Okay, so this is 1. What is 100 mod 5? 0. Okay, so everything after mod 5 I can reduce to the set 0, 1, 2, 3, 4. Can see it? Can see it or not? So what if I do 12 mod 5? 2. Okay. Yeah. Can see it? So about 13 for mod 5. 3. Okay. So everything I can reduce to the set to all to the set of 0, 1, 2, and 3 and 4. You get it? Can get it now. We just care about remainder, huh? Yeah. The number inside Z5 is what? Less than 5, yes. Why? Why? Because if you put 5 mod 5, what do you get? 0. So you go back to 0. So 0 and 5 is the same. Mod 5. Okay? So what I'm saying is 5 is congruent to 0 mod 5. It's the same. They are the same thing. Okay? Inverse okay or not? Inverse. Inverse. Inverse, okay? Okay. So just now, okay, maybe I just use this example and show you again what I want to say just now. So just now you just try 3 times 2 by inspection, right? Okay, let me write here. So this one is by inspection. Okay. So I mean, we also can find the inverse using the extended Euclidean algorithm. Okay. So how to use the extended Euclidean algorithm? So first you have to express 2 and 5, okay, in terms of the GCD of 2 and 5 in terms of 2 2x plus. Okay. So remember we have one way to do it, right? Which is the extended Euclidean algorithm. So how to find the Euclidean algorithm, how to find the GCD? So 5 equals to 2 times 2 plus 1. And then from here, we will get 1 is equal to 5 minus 2 times 2. Okay. If you take this equation modulo 5, you get minus 2 times 2 mod 5. Okay. So what is minus 2 in mod 5? What is minus 2 mod 5? 3. Okay. Which is 3 times 2. Okay. So you also get 3 here. Yeah. So let me, for completeness, I write here. So what is minus 2 mod 5? So minus 2 mod 5 is 5 minus 2. Okay. Okay. No, okay, okay. Yeah, what's the problem? Where's the 5 disappear? Where 5? Which 5 disappear? Oh, why 5 disappear? Okay, very good. So this one is very essential problem here. So why 5 disappear? So what is 5 mod 5? 0. Okay. So 0 minus 2 times 2 is 0 minus 2 times 2. 0 disappear, right? Huh? Oh, wait. Okay. So wait. Okay. So this one is equal to this. You buy or not? You buy this? Do you buy this? Ah. Okay. Yeah, this one very important because although it seems very easy, but a lot of like the student mislook and then they just confused, then they don't know where going. Yeah, this one very important. This is the key part. How we find the inverse is exactly because this term here will go away. Okay. Exactly this part will go away. That's how we found the inverse. Okay. If this part don't go away, then there's a junk here, so we cannot find the inverse. Okay. Okay or not? Still confused? Okay. Yeah. Oh no. One still there. One still there. Yeah. One still there. Yeah. Nothing mystery here. Suddenly disappear. Okay. Okay. So you found the inverse, right? Because you have a number that multiplies 2 that get 1. Inverse, remember inverse 2 times half. Remember this example here. Inverse is something that you multiply, you get 1. Okay. Yeah. Okay. Okay. Inverse of 2 mod 5 in the mod 5 modulo. Okay. Find the inverse of 2 in the mod 5 modulo. Hmm. Great. Yes. Correct. That's correct. That's correct. Because because why? Because if you once I change the question, for example, inverse of 2 mod 7, then this number will change. So what's this number? So what's the inverse of 2 mod 7? Huh? 4, right? 4, right? Yeah, 4. Because 4 times 2 is 8. 8 mod 7 is 1. So you see the inverse will change if you live in a different world. Okay. Okay. 940. Okay. Okay or not? Yeah. Oh, 1 minus 2 more 5 becomes 3. Okay. Okay. Mm, 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 mm. Okay, actually this one we explained abstractly last time. So now we really come into the computation here. So okay. So so what is minus 2? Okay. Minus 2 is the inverse in the additive uh, operation. So okay, let me start another new. Okay, these two inverse actually you guys should like really keep in mind. So this just now we did is multiplicative inverse. Okay, only when GCD of A and M is 1, then you can find the inverse. Otherwise, you cannot find. Okay, but this minus 2 mod 5, right, is called the is additive inverse for 2 mod 5. Minus 2 is additive inverse for 2 mod 5. Okay, so what does this mean is you take 2, okay, and then add to this number here. It is congruent to 0 mod 5. Okay, so what number does this? Last time we spent the rest time to ask you to think about it. Then we said that it's m minus a. So the strategy is to use m, which is 5 in this case, and then minus 2. Okay. And then this will always work. Okay. This will always work. So the concept question is, what number add to 2? You get 0 mod 5. That means you need to add to 2 until you get a multiple of 5. Okay. So the least number you can add, or okay. Yeah. So this minus 2 also live in Zm, right? Okay. So Zm, Z5, so in this case also Z5. So I repeat the Seng process. So it's a 0, 1, 2, 3, and 4. Okay. So what's number in this set here? When you add to 2, you get 0 mod 5. Is what? 3. Yeah. So it's 3. But how do you get it systematically? So you just take 5 minus 2, you also get 3. Okay. Yeah. So both of these you can use inspection or okay. So let me write out. Write out. Write out. So additive inverse of additive inverse of A. Okay, we call it minus A. Okay, is okay, A mod 5 plus is is sorry, M is M minus A. Okay, and then multiplicative inverse of, just now we call it A bar. A mod M is found using the extended Euclidean algorithm. Okay, only exists provided GCD of A and M is greater than 1. Is equal to 1, sorry. Yeah, so this is the summary. Okay, you got question or not? Yeah, this one, yeah, I think very good. The other two class, they don't want to ask question and then they all blur throughout the lecture. Because what we taught last time is maybe a bit abstract. Because I left the exercise inside tutorial. So if you don't see this inside tutorial, then maybe you just don't see it. Okay? Happy? Know how to find inverse now? Okay? Everyone should know how to find inverse. This is very important. Okay, 5 more minutes. Okay, let me mention this theorem and then see how far we can go before we take a break. So, okay, so we can find inverse now. Now we want to solve a system of linear congruence. Okay, so this is called the Chinese remainder theorem. Okay, so why is it called Chinese remainder theorem? because there's an ancient Chinese general called Sun Tzu. Yeah, Sun Tzu. Okay. So Sun Tzu. So what did Sun Tzu did? Let's put the motivation. Okay, let's see what Sun Tzu did. So Sun Tzu want to calculate how many troops he has. Okay. So he first arranged the troops into a row of 9. Okay, 9 of them. And then they line up. And then see that there's one left over. And then he tried a second way. He lined up them in the row of 10. Okay, 10 of them. And then he found that there's like 5 of them left over. Okay. And then third, he arranged them into a row of 11. And then there's one left over. And then from these 3 arrangements, he can calculate that he has around 1,000 to 2,000 troops. Okay. So after you learning the Chinese remainder theorem, you will know how many troops he has. Okay. So yeah, so what's the Chinese remainder theorem? So the Chinese remainder theorem. So let's take n pairwise relatively prime number, positive number. So this one we introduced last week. So pairwise relatively prime means you take any 2 of them, the GCD of them should be 1 prime positive number greater than 1 and some integer. Okay. So the claim is, if you look at the system of linear congruence, x modulo to x modulo mn. Okay. So the claim is this system has a unique solution. But this solution is also up to modulo the product of mn, mi. Okay. This is the claim. Okay, what time is it? 1 minute. Maybe let me finish this proof sketch and then we do exercise after the break. Let you digest this. Okay, so if you don't have example in your mind, it's okay because later we'll do an example. But now I want to construct the solution for you first, a general solution for you, and then see how to solve it. So the proof sketch is, let's define the capital MI to be this. Okay, so let's put it super clear here. So put m, little m, to be a product of mi. Okay, and then set the capital M, capital Mi to be little mi over m. Okay, and mi bar to be the inverse of mi. inverse of mi modulo little mi. Okay, so such that mi is equal to 1. Okay, and then I claim that maybe you can try yourself. Why is this true? But after break, I will tell you why is it true. So I claim that this solution would, namely this solution will solve the n linear congruence above. Okay, then I will leave it here and then. Okay, the claim is this solution will work. You can try and think yourself why this solution works, but after break, I will explain what works. So let's come at 10:02.嗯，
这个是负的，
对，
就是我这个负是跟上次一样的，它就要直接是无减2，
对，
是它的
ADP
inverse，
对，
什么呢？它的 inverse 一定要属于这个。
对，对，对。
为什么是 inverse 属于什么？
为什么要在它里面啊？哦，这是它的定义啊。
如果是语数在它里面，可以，如果是它model 之后的数在里面是可以理解的。这个数为什么要有这样子？
它是定义啊，就是我们要它的定义，对，它的定义啊。
没反应过来。
对，没有，它是定义来的，它是怎样方便？可能上这个礼拜比较抽象一点，它是定义来的，就是你一定要在里面找，就每一个这里对，它是定义来的，它是定义。如果你的 A 是在那个 set 里面，那你的 inverse 也会在那个 set 里面，是定义来的。
OK，
还有，谢谢。OK。
是上面
嗯哼，
这个 A 是什么？
嗯哼，
这个 A 是什么？
这个
上面有个是什么？上面有个横。
这一个只是一个名称，但是最重要是这个 multiplicative inverse。OK，你要问这个是什么？
这个和这个有什么区别？这个inverse和这个inverse，这
哦，对，所以他们的那个形容词不一样嘛，对不对？所以 additive 什么 add 是加嘛，multiplicative 乘嘛，对不对？所以这是加了过后你会拿到0，这是乘了过后你会拿到1。OK，慢慢来，哪里呀？
乘了之后拿到一个，不是这两个乘了之后我得
会拿到啊，对，没错，modify 拿到1，对，没错，这个乘这个 modify 过后拿到1，这个加这个 modify 过后拿到0。
但是这个不是
说错了，请再试一次。
嗯，
这两个加一块不就是等于0吗？为什么要 modify 等于0？modify 0 modify
因为刚才不是告诉你这个减2在这个 set 里面不存在吗？
对
对呀、所以它其实是3来的，可以理解吗？哪里乱？哪里乱？
不是 inverse 才是
嗯哼
3吗？
对
那为什么你又说这个是3？你为什么又说这个负2是3？
负2是3，因为这个负2不存在这个 Z file 里面嘛。OK，这个应该要放一个这个，因为负2不在里面，我不知道什么叫做负2在这个世界，对吗？所以我找到哦，原来这个世界的负2是3来的，可以理解。就像这个，像1/2嘛，1/2没有分数在这里啊，
对啊，
对吧？像这个一样，我没有复数在这个 set 里，对不对？谁要充当这个复数？
把它直接变成 n 减
对，再说一次，呀，
就直接变成这个。
对，
那为什么这里有？
为什么这里有个？它一开始就在。
那这个不是对，
啊，对，
那为什么有个2在这里？
就是我要去试一下这个负2 modify 加2过后是不是0 modify。就我在试它。对，OK。啊，没有，因为 inverse 的 definition。inverse 的那个定义就是你要加了过后拿到0 modify，你才能够讲它是 inverse，不然为什么它是inverse？
零或者出来才是 inverse。
就是
不是末者之后等于1的。
两个，这里有2个概念，一个是加的，一个是乘的。如果你加，对，这里有2个概念，对，这里有2个概念。上星期 tutorial 做了，
看不懂。
看不懂。
最后一题看不懂。
但是最后一题跟今天没有关系。如果算的都做了，
做了。
OK。
什么？到底是什么？
就是 additive inverse。OK。是一个数字。P such that 你加了另外一个号码过后，你得到0。OK。OK。
然后
问题是，然后这个 P 可以用 M 减 A 来的
找
P，对。或者你看在平时的话，在平时的在 real number 的情况下，你可以取减 A 嘛，对不对？但是减 A 不在 ZM 里面嘛，对不对？ZM 里面全部是正，所以对。但是如果你取 M 减 A 的话，它就会活在这个 ZM 里面，你知道为什么吗？为什么 M 减 A 是小于 M？
M
因为 A A 是活在 Zn 里面嘛，对不对？刚才你有提过，在 Zn 里面的东西全部都是小于 m 嘛，对不对？所以第一这个东西一定是真的咯 ，m 减 a 一定是 positive 咯，对不对？A 是小于 a 是小于 m 是小于 m，
这个是 A 属于什么？
对 ，a 属于 Zn，a 是小于 m，然后所以 m 减 a 是大于0哦，对不对？
嗯，
然后还有为什么 m 减 a 会在 Zn 里面？因为 m 减 a 是小于
小于 M。
yes， 它是负数，它是 positive，它又小于 m， 所以它就在 Zn。
A
怎样？
A 为什么是在这里面？
是我要让它在它里面，是我一开始就让它在它里面。
不会有不在这里面。
会有，比如说你要讨论，比如说你讨论，然后让我想，比如你要讨论什么是减100嘛，2
嗯，这个就
但是这题目，你可以把它，OK，可能这个比较少一点，反正这个你可以把它解成-1mod3才开始做，或者如果你要直接做的话，它就是说，嗯，就是说100加一个什么。
嗯
应该有很多啊，这个是有很多，就100加什么数是0.3，对吗？你还行吗？
今天上课
啊，要上课了，你还行吗？
是课约什么？
啊，今天下午，
哦，
今天下午，啊，2点，啊2点到6点，可以啊，可以啊，什么？
这里
就在我办公室448
哪里
办公室 A4448
？A4
448，你还可以吗？
还可以。
呃，
我不是我可以去问问你，但是
可以
现在看了在动。
，OK OK 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 OK，嗯。OK，Okay. Okay. So let's see. So why why this solution here work? Okay. So let's take this solution. Okay. Let's put back into each of this congruence here. Okay. This means we reduce this solution mod little m1, little mi. Okay. So let's look at x mod little mi here. Okay, so this is my proposed solution here. So let's take mod little mi. Okay, see whether it can solve to A1 or not, right? If we can solve to A1, then we can solve this. But they all look similar, so we just do for M1 and then to be the same for all of the others. So let's see what is mod M1. Okay. So let's check what is capital M1 here. Okay. So what's capital M1? So by definition is little mi products of little mi divided by M1. Okay. So there's no M1 exists here. Okay. What about M2? So it's the product of mi divided by M2. Okay. So it contains a copy of M1. Okay. Similarly, Mn also contain a copy of M1. Okay. So that means all these terms here will be divisible by little m1. Okay. So that means these are 0 congruent to 0 mod m1. Okay. So only first term survive. Okay. So only first term here survive. Okay. But we said that this is the inverse of m1 modulo little m1, right? Because this is how we set the m1 bar here. Right? M1 bar is the inverse of M1 such that it is 1 mod M1. Okay. So this is congruent to A1 times 1. So which is A1 mod M1. Okay. So similarly, you can check it for M2, M3 out to Mn. Then only the capital Mi term will survive. Okay. And then the coefficient will survive because we set it to be the inverse. Okay. We set the product of these to be the 1 mod little m1. Okay. Yeah. Okay. Let's see how we use it. Sure, I can go through all this. Okay. Maybe if really we cannot, we just throw away cryptography. Okay, let's see. We want to solve this system of linear congruence. Okay, solve the system. Okay, so it's like 2 mod 3 x mod 2 5 and then 2 mod 7. Okay, so so check that things 3, 5, 7 pairwise relatively prime. Yeah. So we can apply Chinese remainder theorem. Okay. So how to apply Chinese remainder theorem? So following the notation in the proof. Okay. So we have the small m, the product of mi, which is 3.5, 3 times 5 times 7. Okay. And then we need to find what is m1. Okay. M1 is 3 times 5 times 7 divided by 3, which is 5 times 7, which is 35. And then M2 Okay, if you don't understand the proof, you should use this example to like understand what I wrote just now. So 1 divided by 5. Okay. So which is 3 times 7, which is 31. And then M2 is 3. Okay. And then just now I said that M1 bar should be the inverse of M1 mod Mi, which is, so M1 is 3, M2 is 5. Okay. So what is 35 mod 3? Is 2 mod 3. So the inverse of 2 mod 3 is 2. Okay. And then how about M2? M2 is congruent to 1 mod 5. And then M2 bar should be equals to 1. And then 15 is equals to 1 mod 7. And M3 bar is equals to 1. Because, so let me write. So because M1 times M1 bar is equals to 2 times 2, which is congruent to 4 mod 3 is equal to 1 mod 3. Okay? So this is how we find the M1, Mi bar. Okay, it's the number that when you multiply to capital M2, you get 1 mod, the Mi, little Mi. Okay. So if you follow the answer there, so we will write okay. So so okay. So if you follow the proof of this theorem here, so you just substitute this A1, M1, M1 bar here. Okay. So in this case, we got 3 congruences. So we have 2 times M1 is 35 and M1 bar is 2 plus 3 times 21 times 1 plus AN is 2 times 15 times 1, which is equal to 233 mod, which is congruent to 233 mod 105, because this one is 105, which is congruent to 23. Okay. So this solution is only unique up to congruence 105. Okay. Okay. Blur again. Following on. No, I mean, yeah, you need to follow this step here. Okay. So if you start, you should come back to this proof again. Okay. So like follow the construction here. Okay. What is capital Mi? Okay. And then what is Mi bar? And then try to use this example here. Okay. And then help you to think about this construction here. Okay. Okay. And then the next thing you can use to solve, you can use Chinese remainder theorem to solve is, for example, you want to solve I think I can urge you to believe me first, then you can try and test the theory yourself. Don't test it now because The important thing is you know how to do first, because in the exam you need to know how to do. Some of them is direct questions. So so if I want to solve this, okay, let's say I want to solve this. One way to solve this is through inspection. So you find the inverse. Okay, let me just write it down. By inspection, so you know that I think it's 63, 65. So by inspection, 65 is the inverse of 17 mod 276. Okay. By inspection, this is the inverse. So you can multiply 65 on both sides, and then head modulo 1076. Okay. You get what? What you get? 500. Which is modulo 33 mod 1076. Okay. You can go back and test my calculation, but for now you just believe me first. Okay. Because there's too many calculations going on, so I want to show you all the calculations, what you can do. Okay. If you want to test my theory, you can go back and calculate whether I calculate correct or wrong. Because there's too many calculations going on here. And also there's method that I want to show you how to solve this question. Okay. So one question is by inspection. You found the inverse, or you also can use Euclidean algorithm, extended Euclidean algorithm, to find the inverse. Okay, this is the systematic way to find the inverse. Okay, so we can see that we also get 65 is the inverse 17. 176. Okay, so how do we use? So this slide is a bit like a summary of what we did just now. Okay, so this example here. So how to see that 65 is the inverse of 17 mod 276? So you perform the what's that? Perform the Euclidean algorithm again. Okay, this is a last week material. So 17 equals to 491. Okay, and then you do the back substitution, and then you get 6. Don't check my solution. Only if you don't understand what I'm doing, then you can ask. Don't check my calculation because some calculation. Okay. So, hey, did I do something wrong here? I think I do something wrong because I don't have a 5, 4 here. So if I put a 4 here, then this one will become a 6. Okay. So if I take this mod, so if I take this mod 276, okay, you get 17 times 65 mod 6 congruence. Okay. So you found that 65 is the inverse of 1. Okay. And then more advanced way to solve this is to use the Chinese remainder theorem. Okay. So Chinese remainder theorem says that if you have a solution to the linear congruence here, okay, you can also split it into this pairwise relatively primes number. The congruence system of congruence modulo pairwise relatively prime numbers. So what do I mean by that? So since 276 is not a prime, it's a composite, so we can split it into a prime, split into products of prime, okay, by the fundamental theorem of arithmetic. So when you split it, you can find that it is actually 3 times 4 times 23. Okay, so 3, 4, and 23 are relatively primes.
So the system of congruence, so this is equivalent to 17x congruence to 9 mod 3 and 7x 9 mod 4 7x congruence 9 mod 22. Okay, so we can further simplify this because 17 9 greater than 3, right? So we can reduce it to the Z3. So it's 3 congruence to 0 mod 2 x congruence to 1 mod 4 and 17 congruence to 9 mod 23. Yeah. Yeah. Again. The mod 2. Oh, yeah. Okay. So here is 3. Okay. But here I lie a bit, right? Because 17 mod 3 is what? Is 2. Okay. So it's actually what you get first is 2x modulo 0 mod 3, right? But 2 mod 3, the inverse exists. So I can multiply 2 on both sides. To get x congruent to 0 mod 3. Okay. So that's why the first one can reduce to x congruent to 0 mod 3. Second one is just the normal because 17 divided by 4 is 1. The remainder is 1. 9 divided by 4, the remainder is also 1. Okay. So one way you can do is you use the this method again. M1 bar and then M2. So when I write this M2, M1, M2 bar, right, you need to recall the construction inside the proof. Okay. So you need to recall the construction inside the proof. Recall the construction inside proof. Okay. And then you want me to cannot because okay, unless I move it. Okay. Because okay. So if okay, telling a bit lie here. So okay, a lot of things you need to like. Should I tell you? If in a different lecturer, they won't tell you this many things, right? You need to figure out yourself. But if I tell you, feel like you also cannot absorb. Can you absorb or not? You want to absorb? You want to absorb? I can tell you how to use this X here. Huh? Try, okay. So, okay. So if you want to use Chinese remainder theorem, right? Your Chinese remainder theorem, not that there's no one here. There's no one. There's only one here. Okay. But this system here, there's 17 here. So how? You have to remove it before you can use this Chinese remainder theorem here. Okay. So can we do it? Can we do it or not? Is there exists an inverse of 17 mod 23? There's only one condition you need to check. Is there GCD? Is there GCD 1? If it is 1, then the inverse exists. Okay. So since the GCD of 17 and 23 is 1 because both of them are prime, okay, different prime. So the inverse exists, you can translate this system here into all the coefficient of x is 1. Can someone quickly find? I don't know. So what's the inverse of 17x? Okay, use my method just now, Euclidean
a standard Euclidean algorithm. Things. Okay, so Euclidean, a standard Euclidean algorithm. So 23 is equal to 17. 6, right? So 17 is equal to 6. 2 times 6 plus 5. 6, 6. Okay, and then 1 is equal to, if I don't explain, you can understand. Can you see what I'm doing? Yes, okay. I hope you can see. Now you can check whether my calculation is correct or wrong. Maybe I do a wrong simple calculation. Is it correct? Please help me check. Okay, so if you take mod 23, you can see that minus 4 is congruent to minus 4 times 17 mod 23. So what is 24 mod? What is minus 4 mod 23, which is 19? Okay, so now I happily found my A. So my A is actually 19 times 9 mod 23. Yeah, of course you can simplify it. Can you simplify it? Okay, I just simplify it. Let me see. So this one is equal to. Please help me check my calculation. 10. 10, right? Okay, yeah. Okay, good. Okay, so you see, we got this AI here. Okay, put the AI into the corresponding A1, A2, A3. And then M1 is the product of this number divided by the little mi. Okay, so the first M1 is 4 times 23. And then the second one is 3 times 23. And then M3 is 4 times 23. And then M1 bar is the number that when you multiply 4 times 23, you get 1 mod 3. Okay, so follow the construction inside the proof. I already helped you solve to AI. So next you need to find your M1, M1 bar. Okay, there's another method called the back substitution. Okay, what time is it? 10:30. Okay. Wow, need to at least get to Fermat's little theorem. Back substitution. Okay. Can you substitute? Hmm. 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 Oh. Okay, let's go on first. Let's see how. So, okay, best substitution method. So, okay, so first your solution need to solve this system of linear congruence, right? Okay, let me move it down there. Okay, so the first congruence will translate to what? So meaning x will be equals to a multiple of 3, right? Because x divided by 3, the remainder is 1. The 0, sorry. Yeah. Okay. So then you sub for this. So from 1, we get From 1 we get this, okay? Then we call it 4 maybe. So sub 4 into 2. So we get sk equal to congruence to 1 mod 4. Okay. So does the inverse of 3 mod 4 exist? Yes, because the GCD of 3 and 4 is 1. So it actually is 3. So you can take 3 on both sides. Okay. And then you get 3 mod 4. Okay. So what this mean again? So this means K is actually equals to 4 times J plus 3 for some J. Okay. Because this means you divide K by 4, the remainder is 3. Okay. So I'll call this 5 again. So sub 5 back into 4. Okay. What you get is x is equal to 3 times 4j plus 3 for some j. Okay, maybe just compute what's this. What's this? Plus j plus 9. Okay. And then why I sub it back just now? So I got this solution here. I sub this solution back to here because I want the solution to satisfy the second congruence as well. Okay. Now, since my answer here satisfies these two congruence, I also want it to satisfy the third congruence. So I need to sub it back to the third congruence and check what kind of j I have. Okay. So next is so to put it back. So 6 is a number 6. Okay, so sub 6 into 3. Okay, so sub 6 into 3, so it's 17 times 12j. Okay, so you just keep going, and then you will get j is congruent to 2 mod 22. Okay, yeah. Then x is congruent to 12 times 2 plus 23 t plus 9. Okay, which is equal to 33 plus 176. That is congruent to. Okay, because this is a multiple of 276. So this is the remainder after you divide by 276. So you also get the solution that x is congruent to 33 mod 276. Right? Which agree with what we have just now. Okay. Yeah, so there are a few methods you can use to find the solution. Okay, next, this is the one last technical part you need to learn today is this Fermat literature. Okay, so Fermat's little theorem says that if P is prime and A is an integer not divisible by Q, then when you raise A to the power P minus 1, it's congruent to 1 mod P. Okay. So furthermore, for every integer, A to the power P is congruent to A. Okay, So what's the example here? So for example, if you raise 7 to 10, it's congruent to 1 mod 11. Okay. So you got p. If you have an integer that is not divisible by 11, the p, and you raise to p minus 1, is congruent to 1. Okay. So similarly, if you raise 7 to 11, it's congruent to 7 again. Okay. So this is the statement of this command laser theorem. So for example, you can find 7 to 222 mod 11. Okay. So what's this number here? So to find this number, you need to make full use of this equalities here, congruence here. So this means you have to split your 222 to the multiple of 10 first, right? Which is 10 times 22 plus 2. Okay. Which is equal to, okay. And then this thing is a mod 1 to power 22. Okay. Which is congruent to 49. 11, which is congruent to 5 mod. Okay. So this part here is by from literature. Okay. Huh? I think, yeah. Yeah. Hmm? Yeah. Yeah, so I mean, um, hopefully you understand. You confuse them. Let me try and put here. You get it? Wait. What's the issue? What's the issue? What's the issue? What's the issue? Yeah. Hmm. 7 power 10 then 7 power 2 later. No, okay. What? So, oh, wait. So this is the indices, right? Huh? What's this? So this one is 7. Hmm? Say again. Huh? This one? This one, huh? This one? This one? Uh-huh.
You mean this one? Oh, what does this mean, huh? Huh? This one. The 2 is considered outside. Oh, yeah. Right. Okay, yeah, right. So, what should I write here? You mean put here, huh? Put here. Can I? Yeah, can. Unless or I do this one. Unless I do this. Yeah, okay, correct. Yeah, right. Correct. Yeah, correct. Yeah. Correct. Actually, actually, I wanted to write this, but yeah. Okay. Can. Yeah. Correct. Yeah. Yeah. Okay. Okay. Happy. Yeah. Okay. 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 So. Yeah. Okay. In the last minute here, so maybe we just touch a bit on the cryptography, but it's not in the exam. So you just need to know about the principle they use. Okay. And because some of the calculation also quite big, so it's not doable. You will see what I meant later. So cryptography means usually you want to communicate some messages, but you don't want to let the others know, only two of you know, only the receiver and the sender know. So you try to encrypt your message. So you will start with a plain message that you want to encrypt, and then you encrypt into a cipher text message using some function or keys. Keys, if you have the keys, then you can decipher it or encrypt it. Okay. So you encrypt your text message, and then you decrypt your text message, then you will see what you have, see what people want to tell you. So first, the easy one will be called the shift or the cipher encryption crypto. So the key is just one integer number in the ZM. Okay. So what you do is you associate every number, every alphabet, because alphabet is only 26, right? So you take mod 26. So it's Z26. So and then you apply K, your key, your K number, a number in 26 to each number to shift it. Okay. So for example, let's see. So let's say we want to shift all the number by 3. Okay. All the alphabet by 3. So let's say the text is very good. And then you turn them into digit. And then you plus 3 to all of them. Okay. And then you translate it back to text using the table. Okay. So from here, maybe you don't know what is this, but if you do the -3 process, then you will see it's a very good the text. Okay. So this is shift cipher. So the next one is the affine shift cipher. So you not only just add a number, translate the number, you also multiply the number. Okay. But why this work? Because if this number is the GCD of this number, the multiplication here, with 26 is 1, then the inverse exists. So you can find the inverse of this function here. Okay. And then the next one is block cipher. Block cipher meaning you have a word. Okay, you have the key is a block of word. Yeah, a block of English characters. Right. So they have a different association number. So you will split your message into this block. For example, this is a block of 4. Then you will split your message to block of 4. Okay. And then shift correspondingly. Okay. So the first one will shift by the first character in the key, and then second will shift by the second character of the key. And then fourth will shift by the fourth character in the key. Okay. So this means you shift differently. Shift based on the block of English character. So if you want to get back your original text, you just take away the shift. Okay. This is the block cipher. Okay, you shift by block. But all of these three cipher here is called a private key cipher, because if anyone got the key, he or she can easily decrypt or encrypt it. Okay, as long as you know how much is the shift, then you can do the encryption or decryption. But the fourth one is called the RSA crypto system. So this is the public key. So everyone can know your key, but it's very hard to decrypt. We will see in a moment why. So RSA crypto system. So the key here is also two numbers. Okay, the first number here is a product of primes. So the product of prime they're interested in is like of billion digit, because we already proved that there are infinitely many primes, right? So you can find far away like big primes. Okay, so you take the product of two primes, and then this E here is very special. So this E here have to be GCD of this E with the product of P minus 1 and Q minus 1 is 1. Okay, so you will think like, hey, why need to take the prime minus 1? So we just now see that the P minus 1 appear in the Fermat's-Little theorem, right? So we will see in a moment why this will work. And then public key, this RSA is you also convert your alphabet into integers, but it's a 2-digit integers. So meaning if 0, then you put another 0 in front. If 1, you put another 0 in front. 2, you put another 0 in front. Okay, block of integers. Block of 2-digit integers. And then you will group your integers into blocks that is less than the n. Okay, less than this n here. Okay. So we will do we will look at an example later. Then you will raise this m to the power of e. Okay, and then mod the product of primes. Okay, let's see in this example here. So for example, we want to encrypt stock. Okay, using this RSA cryptography. So the key is this 52537. It's a product of primes. Okay, and then 13, the GCD of 13 with 42 and 58 is also 1. Okay, then we will group the message here into the block that is less than 2537. Okay, which is block of 2 characters here. Okay, so after we split them into blocks, then we raise to the power of e, and then take the mod of n. Okay, then this is the final cipher message. Okay, so how to decrypt it? So how to decrypt this message here? Once you got this message, how to decrypt it? So since you know the GCD of E and the product of P minus 1 and Q minus 1 is 1, right? So the first thing we learned just now is you got this, then surely you have the inverse of E. Inverse of E mod the product of P minus 1 and Q minus 1. And then raise your message to this inverse again. Okay. The claim is you can get back your original message. Why? Yeah, why? So if you raise your message to the inverse of E, so you're supposed to get 1 plus a jump of products of P minus 1 and Q minus 1, right? Right. So if it is M, then you're happy because M is the original message. But you still have M to the power K, this thing here. So what's this thing here? So the claim here, this thing is actually 1. Okay. So why is it 1? Because you can use the Chinese remainder theorem again to break this into 2 systems of linear congruence, and then use Fermat's little theorem says that if you raise m to the power p minus 1, it's actually 1. Okay,
So so by the Chinese Riemann theorem that solve these two linear congruence is just 1. Okay. So this part here will become just 1. M to the this whole thing here is 1. Use Chinese Riemann theorem. Yeah. And then Fermat's linear theorem to simplify it. So once you raise it to the inverse of E, then you will just get M. Yeah. Okay. Yeah. Okay. So this is the principle of RSS. So why is it hard? Why is it hard to decrete it? So you see, to find this inverse here, okay, you need to know about P minus 1 and Q minus 1. This means you need to know how to split your primes into product of primes. Okay. But if imagine I give you a billion digit, okay, billion digit n, it is a product of primes. Can you quickly find what's the product, like what two primes that multiply to the billion digit? And they believe this question is hard. So if you can find a way to crack the system, so if you can find a way to quickly split a billion digit into products of prime, then you will crack the system. Yeah. Okay. Okay. Yeah. Okay. Let's take a break until 11:03. During a break, you can come in groups to collect your quiz from last week.
那个没有考试，
对对对，
不然死掉了。
就听一下就好了。
这个不用记吧？
不用不用不用
那个密码
不用不用，
考试，
不用考。
没有，
我们要来
拿。
这种伤心的时刻，那中5分的人就很想打他。哼，刀丁，你死了，刀丁。对，好，对对对。
对。Because you just need three numbers. I mean, you just need the numbers that are relatively prime. Relatively prime. Meaning, GCD of GCD of so and then
哎，你的在前面口不到。
这样就是
一个方法图你就找它试下找它的反分。比如说122嘛，你要写成看到prime，你就看一下什么可以除它，比如说2可以除，就2乘271嘛，这样。然后你再看一下什么可以除71了，就这样除，把它拆开。或者我们在课堂上也有很多那种，如果你要试号码的话，你要试那个 square root， 这个 prime 小过它的 square root， 然后技能，8点技能，不记得。好的。
对。
今天你是我的，对，这个，如果它是这个的话 ，then n has a prime divisor that's the number， 所以你可以从小过 square root 它的号码的那些prime number 开始找，这样。但是两，对啊，什么？
老师，这个还是没有看懂，说为什么这边就是变成，它为什么就是这边的是17，然后这边就是17？
这个也是17，这边也是17。
其实是
哦，对，这为什么这17不见？
怎么回事呢？
因为你看这里这个去这个你会吗？你会去这个？怎么去到2x 等于0？怎么去到2x 等于0？这个。
这边，就是这一
哦，这些你都懂。那你知道这里怎么去到这里？所以17除3余几？那里面的2呢？2 9除3的 remainder 是什么？0咯，等于0咯，可以吗？所以2x 等于0咯。OK， 这个变成2x 等于0咯。那你怎么把这个2消掉呢？不知道。所以你看啊，这个 GCD 和2和1是2和3是1，GCD 2和3是1，所以2的 inverse 就是说有一个号码乘2是同根数1 mod 3。那个号码是2。2乘2等于4嘛，4 mod 3是多少？1，你就这边变成1哦。然后这里呢，2乘0是什么？还是0？
可以，谢谢。
对，找你的那个会手。William Edric. Yeah, okay. Yeah, you don't have? Oh, why? They haven't done.
他在这里。
But do you know your ID yet? You know your ID?
Yeah, I know my ID.
Okay. Okay. Okay, I'll take that. Just need to check your ID.
Yeah, I thought you need to scan or something.
No. Maybe I'll take that then. Because you also come late.
Yeah.
Okay. I'll take that. Yeah.
I have a score.
Ah, so calculate wrong.
Yeah.
Okay, maybe you let me know later and then see whether you got extra mark. Okay. Later.
Thank you.
没有你的，怎么可能
没弄对不对？
？Don't have.
那里还有
One some. Where's the all the how? This. Yeah, that's yeah, there's another one. Okay. Yeah. Don't have. Hello. Okay. Please also take a photo and then return me at the end of the exam. Not exam, lecture. Uwichi not here. Uwichi. Joshua. Evan Wilson. Okay. 单之谦。Uwichi. Oh, this one? Friend. Your friend, yeah. She cannot come. Yeah, she told me already. Check out, yeah. 单之谦。Uwichi. Okay. I think the quizzes for this class has the highest average. Yeah, and then I think question 1, part 2 is the hardest one, but this class got 2 full marks. Yeah, this class got 2 full marks on the question 1. Question 1 is my killer question. Okay, so try listen carefully. If you can earn mark, you should argue with me later. Okay. If you can earn mark, come argue with me.
Okay, so the first one is check the cardinality of the empty set. So empty set contains no element. Cardinality is the size of the set, number of distinct element, so which is 0 because no element there. 1.2, yeah, this is a killer question. So 1.2, I want you to show it's a proper subset. Empty set is a proper subset of set of empty set without using the theorem because I want you to reproduce the proof. So if you can write that you want to prove this two statement here, which is empty set is a subset of the set of empty set, and the empty set is not equal to the set of empty set, then you will straight away earn 2 marks without proving. Okay. If you can write out these two condition here, I'll give you 2 marks. Even without start proving it. Okay. So to prove it, you need to prove these two sentences here. Okay. So first, you want to show that P is a subset of the set of empty set. Okay. Why is it true? Because there's nothing in the empty set. So false implies anything. Okay. So this statement is true. So first part is true. This one we did in the class. And then when we show that every set has empty set and it serves as a subset. Second, you need to find an element in the set of empty set which is not in the empty set. So there's only one element you can take in the set of empty set, which is the empty set. And the empty set is not an element of the empty set, so doesn't work, false. Okay, so 2 is false. So some of you, I think, not you, not sure your class got or not, but they use cardinality to argue that they have different element. Because one is cardinality 1, one is cardinality 0. Okay, so this is the definition of reversal set we have gone through in the week 4. Okay, the second one is function. So function show that it's not one-to-one and show that it's one-to-one, show that it's not onto. So to show that it's not onto, you need to find an element in the core domain such that your fx cannot map to it. Okay, so if you sketch a function is good because for you to to help your understanding. So if you set your function to be equal to 0, then actually you will get a contradiction which is 7 equals 0. Okay, so that means you cannot find 0. And then I realized that we did that in one of the tutorial questions. Okay, so it's about this question here. And then why is it not onto? Because 1 is not a 10 here. And I did some small calculation here, but maybe it's not too clear, I guess. So I decided if you can say that you can't, if you can, as long as you can state that the 0 in the codomain is cannot be attained by the function, then you get 2 marks. Okay, without showing this. But in exam you should say why the number can't be attained. Okay. So I thought this showing one-to-one is quite straightforward because by definition you just suppose fx equal to fy. Okay, this is given, and then you want to show that x equal to y. Okay. This is close to one of the tutorial questions, which is this question here. Okay, you want to show that minus 3x plus 4 is injective. So you suppose fx equal to fy, then you see that with some algebraic manipulation, you will see that x equal to 1. Some of you told me that you also can show using that f is strictly decreasing on the positive part and the negative part, okay, which is true. Okay, if you can show that they are strictly decreasing, then it will imply that f is one-to-one, because in our class, I think we did, if f is strictly increasing or decreasing, then f is one-to-one.
Okay. And then for part 2.2, any interval that doesn't involve zero will give you the bijection of f. Why I asked about this question is because given this codomain here, you can see that the f is not onto. So my intention is, can you restrict the f? Okay, can you restrict the f such that the f is bijective? Okay, so as long as you restrict it to any interval away from the 0 point, then it should be bijective. Yeah, the highest mark overall, I think, is 9. And then I think you missed this easy question here. Yeah, so yeah. So if you think that you can earn more marks, you should come and talk to me later. Any problem with the quiz or not? Is it clear on the answer? Hey. Huh? Oh, okay. Okay, if there's no question, then you can start with tutorial question today. Yeah.可是你 reach 不到0跟这个没有关系哦，你知道吗？跟 reach 不到0跟t 不可以等于1不能除0是没有关系的。对啊，去除0也拿不到0。对啊，跟去除0没有关系。对。再给你一个。这张纸要给我，你要还？这样。解释你的
是一个 set 嘛，那个 set content element set，对哈，那是它的 subset，因为它是它的 element，是吗？
你看啊，这个是这个，可是这一个是这个。没有啊，一样的东西。
它是一个 set，然后遇到一个 element，还是对，归属在 set 对吗？对。
你要想就是这个在这个公开这个。
empty set 它是一个 set content，
对，
它是一个 set，它是一个 set，
没有，这个东西是错的，这是错的。比如说这个呢，结果一个东西在那里，这个不是很少见。如果你真的要的话，我也可以这样。这个也是错的。
这还只是 element 它就不是
没有关系。 这两句话没有关系。啊，对，你还要吗？
还
？OK，那就 OK。
就是三大。
嗯
这个不是一样写的。
，OK，我知道刚才我说的这个地方，然后呢？哪里有错？
然后就我感觉
这个
这个话不是相当于写的这种攻击属于
这个啊，
对。
这个，因为我是要你正，所以 OK，这个可以给你5分，因为这个我本来就说不可以，我要你正的。其实这边至少你会知道，然后这个这个应该可以，这个我觉得可以，因为这个可以，这个可以，这个可以，你是3.5啊？
好像可以。
哦对，3.5、4.5加2分了。OK 啊，这样给我了，还是
我在看。
那你再看看。
这个
呀
写到这里了，是每分还是
，OK，你告诉我为什么还不会的？
就无论 x 取什么，它都不可能是0，因为它在就是分母上。
不严谨，但是可以，至少这是可以。不严谨，但是如果你要严谨一点，就像我这样子做就行。呀，因为有时候有一些极限的问题要处理。
那我画的这个图像，其实它也是
可以
写不到0。
对，但是图像不够严谨，因为如果东西很远的话，我们其实要用
趋向
极限来讲。但是
不会等于0为无限趋近。
哎，你也没有说它是 Discrete 的。其实这个要说了，其实要说，不能够直接讲了。
怎么说？
怎么说？就像我们课堂上那样子说，就是当这个的时候，这个是小于这个样，
就是 f
要 argue 对吗？
我就直接当它，因为这个我觉得就直接看着就
要写的，就写的。加你1.5可以吗？还有吗？
没有，就是
1.5可以吗？
我不会。
加一旁边。
如果我这个写很快的话，它是对的。对，写错是这一个。我就想知道，如果是写很快的话，还是对的。
可是这个等于0倍，这个等于0跟这个是不一样的，对吗？
对。
不一样的。对，你要说哪一个？
就是讲，每个公仔在那个边，它会有一个 x sign。
对，
然后
没错。
如果我现在举例这个零，
你这个哦，你因为你看啊，你看这里，你这个 y 重复用的是不好的，不可以这样重复用。你看这边用 SWE 太不可以这样一直重复用，你要用不一样的东西。
我就是换名字了。
而且你这个 x 跟这个 x 应该是没有关系的，所以你一直重复用那个 variable 不好，不要重复用，就是一直做新的 variable。当然你要讲一个新的东西，你就用新的东西。OK。 然后一个是这个问题，第二个是 OK，所以为什么不说 on 你先跟我说先，你先说先，不要用这个，然后你说给我听，想法是吗？
就是我想表达它，当它是零的时候，
Yeah，
它是没有那个，
对，但是你写的东西不是你讲的东西，
可
对吗
能表达错了。
对，嗯，对，我给你，2分是这个对哈，OK，嗯1.5对吗？对呀，对呀呀，对，所以你有一个问题是这个 x 啊 y 不可以重复用啊
我应该怎么？
什么意思？
啊，你可以用 p 啊 q 啊什么这样 for every p 这个啊 there will be q 这个，但是你看啊，如果我这里我已经有定了什么是 s 和 b，是最好用这里的。OK，因为你就算这里说 R，我也知道你在讲什么。就算这两个是 R，我是知道你要讲什么。对啊，对了，这个 OK，对，
你先问。
我说，
嗯哼，那个说的，
我跟你说，这是空气那边，
嗯，
然后这是
你要这两个，
这两个，
对，你要正它是它，
说了空气是它的体积。
对，可是这个我不可以用哦，你要正这个我只可以给1分吗？OK 啊，我看一下，等一下你写什么先，我看看。哎，你是正这个是吗？
就是我讲到这个，
你讲到这个，对，没有错，对啊，给1.5分哦。那你有没有讲到这个呢？有没有说到这个？
我有说的是空气那个，没事，我说并没有元素，所以讲就是这个。
对，为什么没有元素一个有东西，所以它们不等于？行，
就是这句话是一都是可能没有写特别完整写在。
没有啊，这句话只是说这里没有东西啊，这句话这里说这里有东西啊，所以一个有东西，一个没有东西，为什么它们不等于？
是要加上这句话。
没有，这个是我要的东西，对，是我要，所以这两句话怎么给出这句话？嗯，这两句话怎么给出这句话？
所以是要有这个，
嗯，
这个是几分？2分。
这个2分的，如果能够证明的话，2分的，嗯，能够解释吗？如果能够解释，我就给你多你1分；如果你说得出，我就给了你1分，因为你有这个了嘛，对不对？这个是你有的，因为不可以用，所以没有满分哦。但是你如果能够用这个解释出这个，我可以再给你分，用嘴巴，
直接讲吗？
直接讲，没有办法，至少你们会就可以。
就是要讲出这个是。
对，还是你想想一下再过来。
要不先问我组织一下
你想一下，
我组织一下意见。
为什么？OK，我先给你那个明确问题来，问题是怎么从这两句给出这一句？
这句好。
对，
没有看懂这句话什么意思，就是这个就第一个解释这句话是什么意思？
哦，因为如果你要找x 里，你要取 MD set 里面的东西，证明 x 在这里，但是 MD set 里面是没有东西的，所以这句话是错的。然后所以错，
这第一句话是错的，
没有，第一句话的第一个部分是错的。
第一话第一个，
呀，
对，
所以错的可以 implies 就是如果 false implies false 是 true 嘛，false implies true 也是 true，所以错的可以
证明这个
所有东西就
我还是没有啊，是
所以你怎么讲啊？
什么意思？
OK，所以如果你有一个 compound proposition 是 P implies Q，OK，所以这句话什么时候是对的？只要 P 错，它就一定是对的。可以明白吗？
对，
所以我们说的就是 false implies everything 的意思就是这样。所以只要你是错，你后面讲什么你都是对的。理解吗？
比如呢，这个就是这个是错的，这个是错的，
对，所以一整个是对的，
对的。
OK，
行，
可以，
准备好了。
准备好了，OK。
那我就开始讲。我这句话的意思是，这个集合里面只包含一个元素，就是它，然后所以我们就可以知道这个元素它是这个包含在这个里面的，然后我们这样第一句话就是这样。
没有，那这个证不了第一句话。
为什么？
因为你要取这里面的东西。
取这里面的东西。
对，然后证明它在这里面，而不是它本身在这里面，对吗？呀，
取这个是空姐里没有东西。
对呀，没有东西哦。
对呀，
对呀，
空姐但是空姐是所有的那个集合的
就是没有东西啊，对，
所以这句话可以用，就是算是公理，就是空姐是所有集合的集合。
但是你知道那句话是什么证明？
空姐是所有集合。思考一下。
对，那一个证明就是我要你在这里做的那个证明。
其实所有集合。
就是你要证这一个。
还是要有一个，比如说像 X，就还是要是一个下面的指数。
就是你要取这里面的一个 element。对。
空姐没有东西。
对呀，没有东西啊，所以是对呀，对，所以你取不了啊，所以意思说，所以这一个 proposition 这里这个是 false 可以 imply 所有东西。对，就这句话是对哦，因为你取不了。对不对 ？Q 是 true。哪个？
就是这个。
对，是 implies 全部，这个我也不知道 true 还是 false。对。啊，对，这个。
这个是，哎呀，
没事。
这个不是存在。
呀。
呀。这是 true。
为什么呢？
对 x 等于就把它，我可以把它看成元素吗？这样的这个字，它可以当元素吗？
可以啊，可以。
就 x 就是它。
可以。
或者它就是 x， 就不是矛盾。
什么矛盾？这个。
这个是用来说什么？
这个要说的是，对。
这边要存在，不用任意。
对。
是不是这边要存在？不用任意，任意两个形式。
我只要找到一个
就能证明，
就可以证明。对，我只要找一个他们不同，它就可以证明。我不要每一个都不同。
信息在它条件上有很大联系。
哦，没有，重点是这个定义我记得很清楚。
期中考试会考成这样的。
应该不会太多这样的东西，但是定义你一定要知道。
我害怕考定义。
但是你定义你一定要知道，
嗯，
可能不会这么细节方面。还是你再想想，解释这个。
你说这个
解释我跟你说是解释得出，有学生跟我解释的，
可以解释出。
可以解释出，你再想想。没事，还有时间，没事还有时间，你再去想。在干嘛？这两句话没关系啊，这两句话没关系啊，这两句话你原本的意思
就是证明这个嘛。
对，
我让它变成命题 P，
可以。
然后我想用
我知道。
我想证明它的
对
否命题是错的，就我想证明 P 的否命题是错的，就可以证明 P 是对的。
可以，
哦，
但是问题是这两句话没有关系，就是说，我以为这是空来的，这一个你就说和这一个没关系。
我证的是
我知道这两句话没关系。但是你这个不是这个写法。
我的意思就不是我的意思是，我想证这个是真的，
我的
这个是错误的。
OK，那你要证明有 contradiction。它是错的是什么意思？这个是什么意思？
就是这个是我要证，我想证这个是真的，就要证这个是错的。
没有错，但是这个错的是什么意思？
我这个错，所以我就是这个错的话，这个如果是我先看一下这个是不是对的嘛？
没有，
如果我假设它是对的，
对，
就会有一个 A 属于它，但是并不属于它。
哎，属于那它是不属于它，对，
并没，但是因为
对，
这是空集，并没有一个这样的 A，
没有错，
所以这个是错误的，
对，没有错，
所以我就证出来这个是对的。
对，没有错。但是还有另外一个条件，就是你这个只有证一个吧，因为这个错的话，这个有两个条件，它其中一个是你刚才说的这个条件，或者它这个事情也会发生，就是它是相等的。
它当然不可能是相等的，因为我已经证了这里面是 A 都不存在，A 都这个都不存在 A 了，肯定不可能相等。
但是你有说吗？你有没有说？你有没有说？
要说吗？
要啊，因为你给这个 definition 嘛，这 definition 是 n 嘛，但是所以它就变成 o，所以你给它就有两个可能性，你两个可能性都要说它不可能发生，
可以直接说这个不可能。
你只有说一条路不可能发生，但是还有另外一条路。
就是我如果要是正反的正的话，就必须证明这个会在两个。
对，这个两个就 contradict，这个也 contradict。对，所以这个怕有两个部分，所以才有4分在这里。
直接不可以直接证这个。
没有直接证这个的意思就是
要证这个。
呀，因为因为对，所以你有另外一半，
对的，
可以吗？
对的，
对，
这样子，
我写题目是你，还是我写题目？
你说说看，你说说看，
就是看第二题的身份，这个其实一部分人会怎么 这个几何它是有
对对对，
对，这是不可能。那么上面写的有一个没有元素的，不可能。然后这个是空集数，这个是一排配这个什么在不好？为什么看？很好配合。
因为没有这个 OK 了，这个已经解决了，我现在只是要解决这个吧。嗯所以下次你考试你要写出来，你知道吗？你不会只说这里有这个这个有这个，但是你就要解释这个的话，就代表他们不等，因为它有动态。
分解
中国就就这样，就是这个
可以啊，可以，给你一分。
这么好，
你还要？等一下还我，等一下还 OK，谢谢。
我觉得在那里，那你看我的思路，这个会歧视的，但是你应该没理解我的思路。
OK，你说。
我就说，
啊，
不是零分。
嗯，
你看它有一个元素，我都写在这里，这对应的。
但你只需要另外一部分哦，你只需要到这个 part 了，
哪一部分？这
就他们不是
两个 part 吗？这两个 part，你看这两个 part 对不对？存在一个元素属于空集，所以它就对应了这个，就是它的定义。空集本身就没有任何元素，所以它就是任何元素的子集。
没有，这不是定义，这是 Theorem，这是我们 prove 的，这是我们 prove 的 Theorem，在班上。
啊，这个是我这么原来。
这是我们班上证明的这个，每一个 set 都有。
对，我看过你的笔记，
这个
你的笔记，
这是我们证明的。其实我出的这一题是叫你重新证明这个东西
不能直接用
啊，
不能直接用。
不会直接用。
OK，
呀，但是这一个应该是可以解释到这个。
对，你看嘛，它有一个元素，然后它没有，
呀，
这不就存在第二个元素
明白
就可以了。
明白。我教你两次。OK，你还要吗？还是可以？
我来看，
OK，你再看。
还有问题。
他们不等于哦，这两个东西，这个不等于这个东西，因为这个你刚讲，没有这个不等于，这个不等于不是吗？我们不等于
不等于的，
不等于，
这个不是，
可是这个
不是一个。
我看一下，其实我是在这个，没有，你这个写错了，这个应该是这样啊，对，Yeah，所以它的 x 是啊，就是不是它的 x 是。哎，这个你要的话这样子写。啊，等一下你在讲的是这个呀，因为它是这里面的东西，such that 这个东西在这个里面，但这个在这个里面的东西是 phi 嘛，所以它就，其实你要的 x 其实是 phi。
其实 x 因为可是 x，因为 empty set 里面不可能有东西嘛，所以第二句可能是这样子哦。
没有，你这第一句错，这个不是 x 不在这个 empty set 里面 ，x 在 self empty set 里面。Yeah，
那这可以给我，因为我有写这个，有写这个，就是 always false 出现，所以就这样子哦。就说是 always false。
没有，不是，没有，你要 argue 为什么你的写的东西可以解释到这两个东西才可以有分。那这样什么？第一，你要说它是 subset 的；第二，你要说它们是等于。你要 argue 到这两个，你才可以。
哦，你还要弄还等于才可以。
没有啦，I mean 一个你就半分、两分，一个2分。哦，对，你要 argue 到这个才可以。
OK，方便，这方便。
啊，对了。啊，对，你 OK 了，OK，
我没看过。
OK，你还有。 再给你看看。那你还要吗？还要吗？
不用。
要还给我啊？要还给我 ？OK。对，我要作业也在，我就要记录。
我一会儿还想问，就是这节课讲的，很多也不太理解，
可以，
还有
可以，
就是
我在2点来啊。
前半部分就是听你讲的话，就是完全英语的话，我就基本就是说的。
OK，等下你2点来啊。待会儿你2点来。OK， 好。OK。
我现在就是做题，发现就是现在做题应该就是本身先从这个定义出发。
对，
先从把定义说出来，然后再解释，这样就对。我以后就照这个模式做题。
就这样做。OK。Okay. Yeah, for exam purpose, you should focus on Euclidean algorithm, extended Euclidean algorithm, and then Chinese remainder theorem, the Max Litter theorem. Huh? Bring your own paper. Why do you need a paper? Yeah, just like that. What paper? Left paper. No, we will provide the draft paper. Yeah, we will provide draft paper. Stationaries, water bottle, calculator if you want. I'm not sure it's useful or not. Student card. Okay. Okay. Yeah, let's run through this question. So, first few question ask you to find the inverses or show something is an inverse. And then you can see the 4.46 here, you can see the full power of Euclidean algorithm and the extended Euclidean algorithm. And then how to apply this to show that to find the inverse of 34 mod 89. Okay, you definitely want to go through this example. And then got few similar question. Okay, 4.4.20. Not sure if any one of you did it. So this is the applying the Chinese remainder theorem. Okay. So use the construction of the solution here. Okay. And then find the solution of 60. Mm. 4.4.34. Do you see a lot of power like this and then see something prime? Should come to your mind that you're using the Max-Litter theorem. Okay, Fermat's-Litter theorem, p minus 1 raised to p minus 1 is equal to 1 if the integer here is co-prime to 41, relatively prime. GCD of A and M is 1 because these are two primes. Okay, 4.4.38. There's a lot of powers here, so I'll reduce it using Fermat's-Litter theorem first, and then solve it using Chinese remainder theorem. Okay, because you can see that this 5, 7, 11 are all relatively prime, pairwise relatively prime to each other. Four point 4.40. This one combine the divisibility, Fermat's-Litter theorem and Chinese remainder theorem. Yeah, this one very important. We'll have similar question like this. Okay, So you translate the question of divisibility into the question of modulo. Okay. And then split this linear congruence into system of linear congruence. Okay. Because 42 is a composite integer, so you can split into a product of primes. Definitely you want to study this question too. And then the rest will be regarding the crypto, just for you to play around with the cryptography. And then for supplement 40, this one also a similar question. This kind of question, definitely you want to know. Okay. So solving a system of linear congruence is same as solving one linear congruence. Solving one linear congruence is the same as solving a system of linear congruence. This concept you need to keep in mind. Okay. Solving one linear congruence, you can split into system. Solving a system, you can combine to a single linear congruence. Okay. But how to split? Then you need to refer to the Chinese regular term. Okay. You need to split into numbers that are relatively prime. Okay. Once you split into relatively prime numbers, system of congruence of relatively prime numbers, then you can use the Chinese regular term. Okay. Any question you want me to go in details? You can pick one, then we can go in detail. And if if you can come 2 to 4, then we can also do detail. 2 to 6 today, and we also can discuss in detail, in a super detail that you because in class we don't have that much time. Oh yeah, for 4 hours. How detailed you want them? Yeah, so please return the quiz paper after you take the photos, and then if you want to claim marks, you can come and see me. If not, then I'll see you 2 o'clock later. And what? Nothing. No question or not? No question or not? I still can answer now if you want. Oh, actually, there's one thing need to discuss with you guys because your class clashed with GE15. GE15 holiday. General election. Right? So it's which day? It's the 18, right? 18, you guys holiday. 18 holiday. You guys want to do physical replacement or online replacement, or you want just to watch the recording? Physical. Okay. I give you chance. This is a democratic country. So raise hand. So who want physical attendance, like physical classes? Physical classes. Physical classes if more numbers outnumber, then we will pick that choice. Physical. Hey, cannot put down. Cannot count. Okay. Let me see. One. Yeah. The idea, I think the most free is Thursday, right? Your schedule. So maybe the next week or 25th or 25th November. Straight away after the week 20, is it 25th? Yeah, 25th. 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 Can 25th. Okay. Let me see. I think most of you want physical, then we just physical. 25th can or not? 25th. 25th. Also 2. Oh, this is a discrete math marathon. Huh? One or not? Or which day? Okay, I think most of you want physical. If you don't come, then you don't come. If you want to come, then you come. So when you guys want to fix the physical replacement? Huh? Thursday, 25th November. 25th November. Huh? Oh, sorry, it's 24th. I said wrong. 24th. It's the Thursday. Thursday 2 to 5. 2 to 5. Huh? Yeah, Thursday holiday. 1 to 4. 2 to 4. 2 to 5 or 1 to 4? 1 to 4. Huh? 2 to 5. 1 to 4. 2 to 5. Okay, 1 to 4 or 2 to 5? 1 to 4? 2 to 5. 2 to 5. Voice louder, 2 to 5. 2 to 5, Okay, so 2 to 5. Thursday. 24. 2 to 5, 3 to 6. Okay, 2 to 5. Yeah. 2 to 5. Huh? Okay. It's 9 to 3. Settle, then we go lunch. No, just kidding. So 9 to 12, and then 2 to 5. 2 to 5. 24. Okay, 24 Thursday. Because 18 get replaced. I will make a notice in the Moodle as well. Okay. Okay. After you take the photos of your quiz, please return to me the physical one. Okay, I write. Okay, let me write here as well the notice, in case you lost. Right? 你周四不能
12点到2点有空。
10点到2点，刚刚好啊。2点过后来上我们课。
哦。
等一下，你等一下，不用紧，你不用很准时来也可以，你吃好来也可以的，随性啊，随性。OK。哦，先被录起来了。
3点左右来，吃个饭。
对。OK。等一下。哎，24、7、25，这是17号的，17号3点到，2点到。
好的那个柜子我没有拿到，我想看一眼。
你上一次没有拿到？
不是上一次考了，但是我刚刚坐在下面没有发到。这个，对他们说的这个我没有发到，我想看一眼。
微写。
哎 ，yes。
刚才我叫你名，你没有反应。你要看，你一定要看。有啊，好啊。
这里面
问你问题，
你发邮件或者听也可以。
我可以直接跟我
可以，但是有时候我会选择性用英文，不然的话，等下你们考试也不知道那个英文词。
下午2点你是，
所以下午2点
是吧？
对，
下午2
你们一定要
点
来。
谢谢。
太少了。
对，谢谢。好的，谢谢老师。
这个地方，它这个左边它这个不是已经点了吗？
对，这是 domain，这是 call domain。
对啊，它这已经点出来了嘛？那我翻了一个 interval，
没有，就我要重新设置这个interval such that f 是 bijective。
像它这已经是一个，它已经这个
没有，我要 restrict 那个 function。Yeah， 因为我已经知道在这个里面，在这个 domain 跟 call domain 里面，它已经不是 onto 跟 onto 了嘛。但是我想要 restrict 那个 function such that 这个 f 是 bijective， 可以明白吗？
但是这个答案还是这个 domain 还是这个 r 减0嘛？
不一定啊，你找，我叫你找，我让你找一个新的。
但是在它的那个 call domain 是 r 的情况下，无论怎么样，它都不可能是个满数吧？
我那天其实改了这个题目，我那天有改了这个题目。
你改了？
有啊，我在那个板上面有写，我在那个板上有写啊。对啊，我们
什么？
对啊，我们在板上有写。
我想问，这怎么都不可能？
对，
方式
这个的话是不可能的。这我们有改在那个，我们是周四哈。我们是周四。
我也不知道。
我改了好久，我不懂它什么意思。
你应该要问我啊，那天。
完全不懂。
没有老师下次也是改进。
啊，也是可以。有，我有说，我记得我有说。就是我把 domain 调好过后，然后看它的 range， 它到底是不是 bijective。
哦，
这个 range 就是那个值域是吧？
啊，对。
就是那就是意思是我还给他，我找了一个 domain 的 interval 之后，我还给他就是那个对应的那个 range 要写出来，然后满足它是一个满设。
对。
哦，楼下我来找你，直接过去。
对，直接过去。
不用提前说。
不用。
448。448。
对。
我想问这个是怎么证明？
这个怎么证明啊？
因为我感觉好像没有它是合成。
哦，因为
待会儿加上它也是对。
对，因为这两个加起来可能又大过 m。
哦，这两个加过，
也有可能会大过 m。来，他再把它
再除一次。
对，再把它加一次。
对，那就是这个它的意思就是 a 取 m 的余等价于 b 取 m 的余是这个意思，就是
对。
然后那也可以理解为 b 其实就是 a 取 m 余的余数，就是 b a 除 m。
有时候是这样，有时候是这样，有时候不一定，有时候是这样，有时候是这样。这样的话就不是你所说的东西。
哦。
对，它有时候大，有时候小，但是 definition 就是这个减这个可以被二乘除。
二减它除它可以被哦，对。
对，但是这个不一定是对，
这个不一定。好的。当时还有就是这个算那个 inverse 的时候比如说从这一步到这一步，它其实用的是
没有错。
然后从它到它用的
没有错。也就是
说，其实只要这里出现和这个梦的后面这个是一样的，
没有错，对，就是这样，对。来，看到 ，OK， 谢谢。好，对，好的，对，
对啊。
来，
我不可以这样子出。
不然你告诉我为什么你的可以出到我才不行？ 什么意思呀？
X is an element of 这个，然后它是这个，也是这个。
你怎样证明的？
因为它是函数，虽然是它不是函数的，对，它是函数不是的。
对呀、你没有证明啊，你只是说吧。哦，你有说哈。没有，我说的，我在课堂说你要 prove 这个才有满分，如果你可以说的话，就给你2分了。但是你没有 prove 到，你知道吗？你当然这2句话合起来是他啦，但是你没有证明到这2句话。
没有证明到的。
对。这样还啊，这，对，你要证明这2句话，就是这个要 prove， 这个要 prove。
就是用它的那个
definition。可以啊，其实可以给你1些分，因为至少你知道要 prove 这2个才有这个东西。OK 啊，
可以
可以啊，可以啊，
可以
，OK。
我比你高。
你比他高，哇，开心哦。
老师，其实后面那个是要后面那个，其实我们是要写个解释对吗？那个 on to 啊，
最好啊，最好是要。但是我发现我的那个tutorial没有写到很好，我自己算了。
因为老师在我那边说要写
扣你分了，
definitions，
扣你分。
因为我不知道，老师说要
什么？
用
写什么？我要看一下你写什么。
老师说要用 definitions 来 prove 这个。
对，你写什么？你写什么？你要给我看一下。
我写那个 infinity， 我写 f0等于 infinity。写的这个东西出来。
F is not true because one to need to be included in the domain。但是 infinity 不在这个里面啊，所以你也不用管 infinity 哦。你要管的是0哎。
对，但是not consider 是
啊？
没有，我只是要跟老师确认一下，就是要放 definition 的，下次如果下次有这样的问题的话，最好是放 definition 是吧？
最好是在，
然后就 prove by contradiction， 就 prove 它这个 not onto。
啊，对，完整的话是这样子的，不然你就找我一个。你看你这边这么又犯这个格，这个 infinity 不是 real number。infinity 不是 real number，infinity 不是 real number。没有知道。呀。infinity 哈，infinity 是一个很大的数，然后叫什么？
所以老师这样说，
哪个？因为你拿不到这个数的，你拿不到它。
但是其实我这个也是要 bracket 关掉它，对吗？
你要开关这边都可以，这边要开关都可以。哎，其实如果你发现这题，我觉得有点傻的题，我问错了，可能。如果照我这个问法，其实是一个很傻。
因为日本给了这个款的。
不是因为因为你全部给一个function，只要你切那个 domain，OK 算了 ，OK 可以 OK 算了，我不要讲。然后什么？
没有，
我
只是要确认一下，下次是最完整的方法是 definition proof。
对，那个是最完整的。但是问题是这个不是你错的原因，你错的原因是你没有找到这个点。你没有找到这个点，
所以我没有 argue 这个要不要加分，我只是问这个是不是真正做法，下次要。
反正做法肯定是从 definition 出发。
OK。
但是这个拿分不是因为你不是这样回答，是因为你没有找到这个点。你可能会这样难。对，难是相对的。如果你
没有对你来说难，其他人也会难。
呀，
要明白。
还有吗？
没有，我有。
来。
个不讲，就是小绿一
啊，对，
再
啊对，
多一个，
对，再给多你一分哦。
这样就给。
OK，这样就 OK 了。
下面在你圈是什么？就其实是错型的。
应该没有错哎，只是圈起来你有分哎。
圈2个得1分。这个又是怎么错的？
什么
second
没有，不是你没有，你只要跟我 argue 你的答案有没有解出到这2个就可以。A set of empty set is not a subset.
就是我来说这个。
This is because set cannot belong in an element.
因为 empty set 是一个 element 嘛，对哦。
你说这一个不可以 belong in 这个，
像 empty set 就得有那个 bracket 了。
但是为什么你要讲它是 element 呢？因为你觉得它在它里面。
是在这边吧？
因为这个没有 bracket 嘛，不是就是一个 element 一样哦。empty set 是个 element。
没有啊 ，empty set 其实是这样写的，也是一个 set。
哦，
可是你都叫它 empty set 了，对不对？
这个
没有。
如果你讲 a set cannot belong in empty set， 这样就可以，这样就可以了。就是刚才我写的东西嘛，这个不会，这个因为 empty set 没有东西。
那我再讲，我听听。那我再我这个我自己有。
OK 啊，还有吗？
这个的 notation 错了。
notation 错，因为你是给 fx 哦，我要 x 哦。这个 set 应该要有 contain x。domain 呀。呀，如果你写呀，其实如果你就算这样子写的话啊，这样也是有一点难看啊，因为你还要我去算嘛。
刚刚按这是我。
你只要选一个 interval such that 它没有 contain 0就可以。如果你选来，for example 0到1也可以，0到2也可以。
这个我不是特已经还不是很多了。
怎么没有分呢？OK， 你这样子写有一点奇，只是写法有问题而已啦，就写法有问题罢了，纯粹就是写法有问题。你要讲的是没有一个 s 可以去除它等于0嘛，对不对？但是这种东西很难讲，因为这种东西是要用那种 limit 来解释的，所以 instead 我们 pass by 这个问题，我们就直接这个是 equivalent to 7等于0，然后就用 contradiction。呀，可以给你2个这个。这个有一点难解释，不要进到这里了，这里有一点难解释，直接 pass by 它，用7等于0就可以解释。OK， 可以吗？OK，
还有道理。
OK。
我再确认一下，就求这个inverse，我用大白话说，其实就是找一个，比如说这个例子，
对，
就找一个数，让它乘2，完了除17的一个。
这就是它的定义，就是这个。好的，没有算到分啊。OK， 其他的？其他 OK 啊？
那些
可以明白吗？我讲的答案，可以明白。等一下有来吗？
这不能这样子说。
哪一个？
就讲我找他的 inverse 给你，
那你找他 inverse 给我。
他 inverse 也是一样。
但是如果他不 onto 哦，其实他 inverse 就不存在哦。所以它的 inverse 只存在于这一个确0的时候。呀，其实它 inverse 是不存在的。你 formula 写得出来， 但是如果你放进这个 domain domain，它是 define 不出，因为气不能被领出嘛，所以它的 inverse 只存在于，也是在这个世界罢了，在这个世界罢了。所以如果你要让它真正是它的 inverse 啊，这两个人要活的世界是这里。这个，他们才可以互相是他们的 inverse。诶，这么我画一个箭头，
觉得世界好难
啊？
就觉得世界好难。
为什么？为什么？
不过同时也觉得那些发明这种东西的人，
但是如果你能够找到 inverse，就代表这个东西其实是 bijective。可以吗？可以吗？
是来得及吃饭吗？
来得及吃饭，来得及啊？怎么？
没有啊，我是说2点了一下，我就想着来不来得及吃饭。
1点2点来10点，来得及哎。来，哎呀，但是如果你想到 inverse 也是很神奇一下，这么你忽然间有 inverse 这个 idea 出来？你讲一下你这么有 inverse 这个 idea，如果合理的话，给你写分。
图说，真的，你们来的图说用印度什么？
它不是因为你那个它是一样的嘛？你inverse的时候也是这个不来这个。
啊，对 ，OK，然后怎么会可以解释到这个 one to